UMKM yang akan bisa meningkatkan kemampuan untuk memiliki daya saing dan meningkatkan perekonomian di bidang makanan terkhusus tujuan meningkatkan relevansi
program studi teknik mesin merupakan salah satu program studi di Institut Teknologi Indonesia yang telah melaksanakan kegiatan Merdeka Belajar Kampus Merdeka atau MBKM sejak awal 2020. Sejalan dengan diterbitkannya Peraturan Menteri Pendidikan dan Kebudayaan Nomor 3 Tahun 2020 tentang Standar Nasional Pendidikan Tinggi.
Kita ingin melakukan kolaborasi antara universitas dengan berbagai macam pihak-pihak di luar universitas.
PT Komatsu Indonesia menjadi mitra kerja magang industri mulai April 2021. Beberapa kebijakan internal termasuk pembentukan tim MBKM telah diberlakukan di Institut Teknologi Indonesia. Sebagai langkah awal pelaksanaan MBKM, dilakukan kunjungan ke PT Komatsu Indonesia oleh Rector, Wakil Rector, dan Ketua Program Studi Teknik Mesin pada bulan April 2020. Kerja magang melibatkan 4 mahasiswa program studi teknik mesin IT, yaitu Ismail Nur Fahmi, Reza Nur Rahman, Asep Firmansyah, dan Indra Wira Widyadana. Kerja magang dilaksanakan selama 6 bulan, di mana 2 bulan pertama dilaksanakan di PT Komatsu Indonesia dalam bentuk class activity. Dengan tujuan agar mahasiswa dapat beradaptasi dengan budaya kerja industri manufaktur. Kemudian, dilanjutkan di supplier PT Komatsu Indonesia di daerah Tegal selama 4 bulan untuk melakukan improvement proses manufaktur. Pada tanggal 27 Mei 2021, dilaksanakan serah terima 4 mahasiswa program studi teknik mesin Institut Teknologi Indonesia dari PT Komatsu Indonesia kepada suppliernya yang berada di Tegal, yaitu PT Milako Teknik Mandiri, PT Japra Mandiri, PT Prima Karya, dan PT Intan Pratama Jaya untuk melaksanakan kerja magang guna
Pertanyaan.
Oh, bikinan sendiri.
Padahal aku pengen tapi orang wani ganti.
Oh, kirain Pak Abu.
Enggak.
Bener Pak Abu bikin.
Ganti.
Hebat bikin sendiri.
Ya?
Tempat-tempatnya bikin sendiri.
Nah, di rumah numpuk tape.
Oh,
Bojoku tuh kan, suamiku tuh kan
Suka
senang tape. Ubruk-ubruk nang di nang kulkas kan, kalau hanya tape mentah gitu kan kayaknya biar gimana tak olah.
aku ya senang tape.
Aku pengen doa itu lewat tangguh.
Itu tape itu juga makanin.
Tape itu kan yang
Tape ketan.
Matangku sih mules. Aduh.
ya aku tengeleng, aku kan biasanya seneng tape lah, kok malah mules gitu.
Sekarang mules, sekarang nggak tahu ini kenapa
Aku
tiba-tiba.
pokoknya yang penting jangan pedas aja. Kalau
Ini
pedas
kayaknya
spontan.
aku kecentok pedes aku ya.
Hah?
Kecentok pedes aku.
Oh, ya.
Yang sejak itu kan, sejak lebaran itu kan.
Oh.
Pokoknya kalau pedas lambungku udah bener-bener.
Direct sekarang nggak berin aku. Kadang suka pengen gitu.
Iya itu kegoda aku
Kegoda.
kemarin minggu aja banyakan apa bikin sambal ya makan juga ya. Jadi kita di sini aja nih ya.
Ya kalau sekarang juga apa sih ya namanya sehari. Udah banyak anak-anak. Nanti kalau ke sana kan keluar masuk nih Indonesia repot aku. Ampun dah.
Aku ingat nggak? Nah, di sini enggak. Kalau baca suratnya sih, itu enggak. Ini berarti aja online. Kayak hero online.
Kan kamu makanya tante nggak keliling itu karena kemarin tante pikir
Recording in progress.
And for those who are online via Zoom meeting, please mute your voice and also turn on the camera because our agenda will be about to commence. Good morning. Welcome to General Lecture and Signing Ceremony of Implementation Agreement for Joint Research on Creating a Phytoplankton Fishery Observing Program for Sustainable Local Communities in Indonesian Coastal Waters today, Tuesday, 4th of July, 2023. This general lectures and signing ceremony are organized by the North Pacific Marine Science Organization, or PICES, in collaboration with Institute of Technology Indonesia, or ITI, the Honorable Rector of Institute of Technology Indonesia, Dr. Insinyur Marzan Aziz Iskandar, Ipu S.Hut, and our Vice Rectors, Professor Dr. Insinyur Dwita Swastianti M.Si IPM, S.Hut, and Dr. Insinyur Sidik Barsudi MT, Excellencies, delegations of the North Pacific Marine Science Organization, and the team of the project creating of a phytoplankton fishery observing program for sustainable local communities in Indonesian coastal waters, Professor Mark Wells from University of Maine, USA, Professor Charles Strick from University of Toronto, Scarborough, Dr. Shion Takemura from Ministry of Agriculture, Forestry, and Fisheries, Japan, and Dr. Daisuke Ambe, also from Ministry of Agriculture and Fisheries, Japan, Dr. Naoki Tojo from Hokkaido University, Japan, greatest added gratitude is also addressed to Dr. Sasa Sofyan Munawar, M.Si. from National Research and Innovation Agency, BRIN, Indonesia. Professor Dr. Iskandar I. Sasumar, M.Si. Arief Rachman, M.Bio.Sc. also from BRIN. I would like to also greet our head of study program, Institut Leonita M.Si. from Agricultural Industrial Technology of ITI, and also Dr. Insinyur Wahyudin S.T.M.Sc. from Chemical Engineering Program. My name is Garizi Matini. It is an honor for me to host you in this special occasion of general lecture and also signing agreement ceremony between the North Pacific Marine Science Organizations and Institute of Technology Indonesia. Before we continue our ceremony, let me announce you to our agenda for today. We will start from
diambil aja. Kalau ada foto-fotonya gitu juga
technology. Please, everyone.
Ini SOP juga ketemu lagi nih.
Those who are online via Zoom meeting, can you mute the voice? Thank you very much. Let me continue the agenda for today. Go to our first agenda for today, that is the committee report, organizing committee report from our head of Agri-Industrial Technology program. Please welcome to Insinyur Sinta Leonita M.Si. So the floor is yours. Thank you.
Bismillahirrahmanirrahim. The Honorary Counselor of Institut of Teknologi Indonesia, Bapak Dr. Insinyur Marzan Aziz Iskandar, delegation of the North Pacific Marine Science Organization, PICES, Professor Maxwell from University of Maine, Professor Charles Tripp from University of Toronto, Dr. Sion Takemura from Fishery Research Agency, Japan, Dr. Daisuke Ambe from Fishery Research Agency, Japan, and Dr. Naoki Tojo, yes, okay, yeah, from Hokkaido University, and Derajat Seto from University of Maine, and Arief Rachman from BRIN. Head of Research Center for Environment and Clean Technology of BRIN, Bapak Dr. Sasa Sofyan Munawar, and the head of Research Group, or Dr. Agung Riyadi, or Bapak Dr. Joko, ya, and his researchers from BRIN. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, salam sejahtera bagi kita semua. Pertama-tama kami panjatkan puji syukur kehadirat Allah Subhanahu wa Ta'ala, karena atas rahmat dan hidayahnya kita diberikan kekuatan dan kesehatan sehingga dapat berkumpul dalam acara General Lecture di kampus Institut Teknologi Indonesia. Tentunya di sini kami menghadirkan narasumber para ahli di bidang kelautan, yaitu the North Pacific Marine Science Organization atau disingkat PICES. Okay, on this occasion, we would like to express our gratitude thanks to the Counselor of ITA and all ITA management and academics, the delegation of PICES, the head of the Center for Environmental Research and Clean Technology of BRIN, and his staff, as well as all the participants and inviters who have attended this event. Ladies and gentlemen, on the occasion, allow us on behalf of the organizing committee to report this following. The purpose of the general lecture organized by ITI and PICES supported BRIN and various other stakeholders is to increase knowledge and increase the capacity of human resources in the field of marine science and technology for monitoring aquatic environmental resources in coastal areas and small islands. Approximately 100 participants and inviters attend this general lecture from PICES, ITA, BRIN, and other government levels in the Tangerang region and Banten province. In this general lecture, several materials related to the application of technology for monitoring water resources and environment, as well as various phenomena in the marine science field, which are currently globally uses, will be presented. To strengthen support for cooperation with PICES and other institutions at this event, a cooperation agreement will be signed between the Agro-Industrial Technology Study Program and the Chemical Engineering Study Program with PICES, and followed by the symbolic handover of the Plankton Analysis Toolkit or Plankton Scope from PICES, which represented by Professor Maxwell, to the Counselor of ITA and BRIN. Finally, we asked the Counselor at the end of Primax to open this general lecture. Once again, we, on behalf of the committee, would like to thank the experts from PICES and Indonesia who were willing to attend and contribute their knowledge in this general lecture. Hopefully, this activity will benefit all of us and can contribute to the development of science and technology globally in the international world, including in Indonesia. Thus, I convey this short report. I hope this general lecture will be useful for all of us. Selamat mengikuti general lecture ini. Terima kasih, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Ibu Sinta, for your remark. Excellencies, distinguished guests, delegates, ladies and gentlemen, I would like to also invite our Rector, Head of Institut of Teknologi Indonesia, Dr. Insinyur Marzan Aziz Iskandar, IPU, to deliver his remark. Without further ado, please welcome Dr. Insinyur Marzan Aziz Iskandar. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, salam sejahtera untuk kita semuanya. Our honorary guest, special guest today, delegation from PICES, the North Pacific Marine Science Organization, Professor Maxwell from Maine University, USA. Welcome, Prof. Professor Charlie Trick from Toronto University, Canada, Dr. Shion Takemura from PICES and Fishery Research Agency, Ministry of Agriculture, Forestry and Fisheries, and Dr. Daisuke Ambe, also from Fisheries Research Agency, Japan. Mr. Derajat Seto, Indonesian, but say in Maine. Welcome. Head of Research Center for Environment and Clean Technology of National Research and Innovation Agency, BRIN, Dr. Sasa Munawar, Sofyan Munawar. Welcome, Pak Sasa. Vice Chancellor of ITI, Head of Bureau head of center, ET lecturers, students, ladies and gentlemen, all participants, both those who are present offline as well as online through Zoom link or YouTube. Praise and gratitude let us raise to the presence of Allah Subhanahu wa Ta'ala, because by His grace and guidance, we are given strength and health to gather in this beloved ET campus. Welcome to our green campus, Prof. For a public lecture event, particularly, I would like to welcome the guest lecturer from the North Pacific Marine Science Organization to Indonesia. Welcome to the ET campus. I also express my sincere thanks and high appreciation to the PICES delegation and experts in the field of marine science, as well as the speakers from Indonesia who have been present and will deliver their lectures shortly. I would also like to thank BRIN, represented by Dr. Sasa Sofyan Munawar, Head of Research Center for Environment and Clean Technology, as well as participants whom I apologize for not being able to mention individually for their presence in this event. Ladies and gentlemen, as confirmed by the committee, the public lecture is organized with the aim of increasing knowledge and enhancing the capacity of human resources in the field of marine science and environmental resource, monitoring technology in coastal areas and small islands. This is highly beneficial in expanding our insights in the field of marine science and technology, especially for students, researchers, and scientists from our campus, ET, BRIN, and other scientific institutions. Since 2022, ET has been collaborating with PICES and BRIN to conduct research and community service on topics that are highly relevant to Indonesia's geographical conditions as an archipelagic country. This topic aligns with its vision, mission, and role as a university founded in 1984 by Professor Dr. Engineering B.J. Habibie, the third President of the Republic of Indonesia and former Minister of Research and Technology, with the vision of being technology-based entrepreneur university to address national and global development challenge. We place great emphasis on technology development and enhancing human resource capabilities as the foundation for driving the development and utilization of natural resources, including marine science, to support national development acceleration. Through this public lecture activity, it is hoped that it can inspire and expand our knowledge in the field of marine science and technology, and of course in line with the PICES program. May the results of this collaboration benefit all of us and contribute to the development of science and technology globally, including in Indonesia. I'm confident that the research outcomes will be highly valuable for the development of environmental monitoring in coastal and marine areas. Therefore, I fully support the continuation of this joint research. In addition to the public lecture, today we will also hold the signing of cooperation agreement between PICES and two study programs at ET, namely the Agricultural Industry Technology and Chemical Engineering Study programs, followed by the handover of the plankton scoop to ET and BRIN. We would like to express our gratitude to PICES for their valuable equipment and systems, which supports the smooth progress of our cooperation in building human resource capacity in Indonesia. As Rector, Chancellor of ET, I wholeheartedly support various efforts to build synergy in order to enhance the competence and quality of Indonesian human resources. Therefore, on behalf of ET family, I would like to express our gratitude to our colleagues from PICES for graciously coming to deliver the public lecture at ITI campus and for various other activities that are highly beneficial to all of us. With that, I would like to conclude this brief speech, and with recitation of Bismillahirrahmanirrahim, I officially open the public lecture event. Thank you very much. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Pak Marzan, for your remark. The second remark will be delivered from Dr. Sasa Sofyan Munawar, M.Si, Head of Research Center for Environment and Clean Technology, National Research and Innovation Agency. To Dr. Sasa Sofyan Munawar, the time is yours.
Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorary Chancellor of the Institut of Teknologi of Indonesia, Dr. Marzan, Aziz Iskandar, M.Si, PU ASEAN.Eng, and along with all of IT leaders, IT academician, and then also generally to all delegation from the PICES, from Maxwell, Prof. Charlie, Dr. Sion Takemura, Dr. Naoki Tojo, and also Dr. Desuke Ambe, dan juga Pak Derajat Seto sebagai bagian dari delegasi. So I'm here with one of the research group in my research center. Professor Sohendar is one of the our researcher, and also another member of the research group, Dr. Joko, Dr. Agung, and also Ibu Haryanti and Ibu Akira. So, and also Pak Arief, also from BRIN, but from other research center. So it's my pleasure to can join in this meeting, and thank you, Prof. Pak Rector, that was invite me to join in this meeting. So first of all, let's give praise and thanks to Allah Subhanahu wa Ta'ala that today we can gather and together at this campus to attend the general lecture will be delivered by several marine science experts from PICES and then also from Indonesia. So as you know that it is good opportunity for us that convey BRIN support for this collaboration that has been carried out by ET and BRIN that was signing the MOU in Lombok maybe this year or last year? This year, January. So many things, many jobs, so I confuse the time. So I think this activity is also a venue for the implementation, for the collaboration between ET and BRIN, also with the PICES, which has that hopefully activities can continue to be developed to strengthen the capacity and capability of Indonesian researchers, especially from ET, student or the student from various other institution, our researchers, and also the researchers from the abroad, especially from the PICES group. Then we hope also the support from BRIN in this collaboration in the case from our research center, we have some area that we already agreed in the past of our MOU on the development of agri-industry with the environmental insight, yeah, environmental management model, and also the utilization of environmental resources. Also, we have an area of the collaboration on the chemical engineering, environmental, and the clean technology. Maybe I will not compare the long speech. I wish you have heavy participation in this good general lecture program until the end of this meeting by directly in this room or by Zoom and YouTube, Pak Rector. We hope all of the participants can get opportunity to get some information about the plankton analysis equipment that I saw in the room before, the big, oh here, big bag, yeah. Maybe we'll deliver to Indonesian part today that I hear that will be signed. I think this is good. Pak Rektor, mungkin bagi kami di BRIN, Riset BRIN dengan situasi sekarang ini sangat menguntungkan bila mana peralatan ini ada di IT dan kita bisa terus join riset. Ya, ya. Tapi ini tip satu di sini aja. Kalau urusannya dengan BRIN panjang begini ya. Nanti belakang. So it's very, I think, good tools that we already discussed in the Pak Rector room. I hope that also Pak Arief informed that now on the ongoing development of the artificial intelligence, so that in BRIN also they have some other research center that co-focus on the artificial intelligence research. So thank you very much for kind of the attention, and I hope that this meeting will be successful. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Pak Sasa, please stay put. Can you move here because we have a little souvenir for you as our gratitude. I invite Pak Marzan to give the souvenir. This souvenir will be our gratitude to BRIN from ET, and we hope our joint research will be lasting forever, for a long time. Thank you very much for coming to this occasion, Pak Sasa, and all the researchers in National Research and Innovation Agency. Thank you. All right, going on to the next agenda is the introductory speech from PICES and about the project on creating of Phytoplankton-Fishery observing program for sustaining local communities. Ladies and gentlemen, please welcome Professor Mark Wells.
twist, yeah. This. Gotta go. You have to twist the. There we go. Okay. Time's up. I have to sit down now. There we go. There we go. Okay, very good.
Yes,
Thank you.
Prof. You may continue.
Thank
Sorry for the inconvenience.
No, my fault. Well, I would like to begin by expressing my thanks to the director, the ITI family, the BRIN, for the opportunity for us to come and present some of our project and some of the ideas of things we've been working on for the past little while. So we're starting a new project here. And what I'd like to do over the next 10 minutes is try and introduce that topic very briefly. But it's a project on creating a phytoplankton fishery observing program, try and help local communities sustain themselves from their local fisheries in Indonesian waters. It's funded by the Japanese Ministry of Agriculture, Forestry, and Fisheries. It is led by Dr. Makino and Dr. Takamura and myself, along with some others, and in particular with some strong partners here in Indonesia. So what the project is, the objective is to try and help local communities, small-scale fishers and local communities, to monitor their ecosystems and their coastal fisheries. And essentially, there's three goals. It's spread into two prongs. The first deals with fisheries to help them develop activities to monitor using smartphone-based technology, something we call fish GIS. I'll tell you a little bit more about that in a moment. And to look at one aspect of the fisheries, which is Ciguatera fish poisoning. And that is a toxic, it's a result of a toxic benthic algae. And I'll talk a little bit more about that in a moment. But basically, it's to try and help communities understand their fishery, to detect the presence of this potential problem, and if the problem is there, how to avoid getting those contaminated fish onto their tables for families. The project leaders are scientists from 6 member countries represented by the flags up here: Canada, the United States, Korea, Russia, Japan, and China. But most importantly are our Indonesian partners. And I'll highlight 2 people here, your own Professor Suhendahar and also Arief Rachman from BRIN. The 2 have been very critical both in the past projects and in this current project to make sure that this is feasible. This particular project, the focus is going to begin in the Gili Matra Islands of Lombok. Now, the project builds on the previous project, which was building local warning networks for the detection and human dimension of Ciguatera fish poisoning. That project helped create and refine a smartphone application called Fish GIS. It looks like this. You can download it for free. And what it does is enables users to collect images, in other words, data, both on fisheries and aspects of water quality. Very briefly, I want to walk you through what those are. First, if we begin with the water quality, because you can't have good sustainable fisheries without good water quality, without understanding that water quality. The app uses within it another app called Hydrocolor to look at aspects of water quality. The 2 aspects that really are focusing on here is the amount of chlorophyll in the water, which represents the amount of plankton. And later this morning, we'll talk more about those plankton. And the second is looking at the amount of suspended particulate matter. Now, in this image right here, this is a global surface chlorophyll determined by satellites. The hydrocolor app uses exactly the same technology, only using photographs of the water, of the sky, in order to help you understand how much chlorophyll is present. The amount of chlorophyll is basically the amount of food that can help support a fishery. So that's one aspect of the water quality. The other aspect that we look at is the phytoplankton community itself. So not only the amount of chlorophyll that may be there, but who are the phytoplankton that's there? Because there are some problematic species that can cause, for example, ciguatera fish poisoning. Now, in the past project, we used a microscope that was the fold scope, an origami microscope, a very powerful origami microscope that you could hook up to a smartphone and take images of the plankton that then could be used to identify the species of phytoplankton that are present. Those photos would be sent to Arief Rachman, who is an expert in phytoplankton ID and would be able to determine whether or not problematic species were present or not. In the new project, we're going to be using a more sophisticated way of doing that, planktoscope. Planktoscope essentially is a microscope where water flows through it, and it takes images as the water is flowing through it and allows you to collect a lot more data than can be done with the fold scope. It's a very low cost instrument and very easy to operate once you learn the basics. Undergraduate students, all of you there, would be able to operate this without any trouble whatsoever with just a little bit of training. So as I said, there's two prongs for this. We're interested in the plankton to understand whether or not, first of all, how much food is there for the fish, but the other aspect is whether there's problematic plankton there. The other prong of the project is to help with the fisheries, to allow local communities, fishermen to understand how their fishery is basically operating. And so the smartphone app FishGIS also allows individuals to take photos of those fisheries, of the fish that they're catching, so that you can understand the diversity of fish that are being caught in a given area, because the higher the diversity generally means the more healthy environment. If you start having lower diversity, it tends to be perhaps problematic. So if you see trends with time going towards lower diversity, then that can indicate that there's some problems coming up in the fishery. So in this app and in this project, what we're going to be doing is developing AI to try and identify the species that are there. Fishermen will tell us what those species are, but we also want to understand if they'll do it automatically, to do it faster. The other aspect that we can do is to use that image analysis to identify the size of the fish. Now, later this morning, Dr. Tojo will be talking to you about fisheries and how sustainable fisheries may operate. And two of the key parameters are, what is the diversity of fish and what are their size? Because as the size starts getting smaller, it suggests perhaps the fishing intensity is too high for what the environment can support. So this app will allow us to be able to look at that. I want to turn back now to that ciguatera fish poisoning. What is that? What do we mean? Well, ciguatera fish poisoning is a result of a benthic harmful algal species, a dinoflagellate. It's a phytoplankton cell that is in the water column, but also likes to stick to surfaces and grow there. Ciguatera fish poisoning results from the consumption of reef fishes that contain the toxin that's produced by a small subset of these benthic algae, these benthic dinoflagellates. One of them, it's highlighted here, is Scambridiscus toxicus. It grows on coral, seagrass, and macroalgae. And what happens is, as the fish feed, they accumulate that toxin. The toxin is shown down in here. It's what we call it lipophilic, which means that it likes going into fat. It stays in fat. So as the fish consume their food, the little bit of toxin that's there in this single cell starts getting accumulated in the fish. And it biomagnifies up the food web. So that as you eat older fish and larger fish and fish higher up the food chain, there's a greater chance of getting this toxin at high enough levels to cause problems. The problem with identifying ciguatera fish poisoning is the symptoms vary tremendously, both among individuals and at different times. They include things like diarrhea, nausea, vomiting, muscle and joint pain, tingling. But these symptoms can be due to things other than ciguatera fish poisoning. So it's very hard to be sure that you have ciguatera fish poisoning when it first starts emerging, okay? So if you have a few cells present, there's not enough toxin to become a problem in the fishery. But as those cells begin to multiply and the population of those toxin-producing cells gets higher and higher, then the accumulation of that toxin starts reaching thresholds where suddenly it's very clear that you have ciguatera fish poisoning, okay? So the point of this project is to try and help us understand the distribution of these particular organisms and their relative abundance. Now, Arief Rachman has been doing a lot of work in this and others in Indonesia. They've been looking at benthic dinoflagellates that can potentially cause ciguatera fish poisoning across a wide range of areas here, and they can be found, but they're found at very low numbers. Not high enough to be a problem yet, it appears, in Indonesia. Now, the reason why we are concerned about ciguatera fish poisoning is because in many tropical nations, ciguatera fish poisoning we can see builds in as the human influence on the coastal ocean increases. So as more anthropogenic stress happens in those coastal reef environments, we can see the ciguatera fish poisoning occurrence increasing. So the idea here is we want to provide the tools to allow communities and fisheries and others to understand the relative abundance of these benthic algae that can cause problems, and to make sure that we don't see their numbers increasing. Because if we do, we know that steps will have to be taken. So in the current project, the plan is that we're going to create what we call a case study site, or if you want, an organizational site. And that's going to be in the Gili Matra Islands of Lombok, and where we are going to use training to try and establish an observation network of the local reef conditions and the fisheries catch. So from the fishery side, to try and understand what is the state of their fisheries and make sure that that fishery can remain sustainable, okay? So we're looking for indications with time of change. Right now, it appears the fishery is doing very well, which is good, but we want to be able to see whether that begins to change with time. From a benthic hab perspective, we want to help local communities assess the state of their local corals from the perspective of harmful benthic algae, be able to detect the presence of those cells in that reef environment, and then to help, if those concentrations of cells start getting high enough, to be able to avoid the transfer of the contaminated fish to the tables of families. It may be ciguatera fish poisoning can be very local. So in other words, one part of an island, one part of the fishery in some areas, in other nations, that can be problematic, where another part of the island, it's not an issue. So be able to identify where these problems might develop will be very useful then for communities. Now, we present this here, we're excited to present this here because we are hoping that you will find this to be interesting enough to perhaps want to get involved, to start thinking about how we might be able to use these tools. And we had this discussion this morning about how we may be able to help set up programs for students to be able to utilize tools to do different aspects of this type of work. And so with that, I'll just close and thank again for the opportunity for us to present here.
Thank you, Prof. Mark, please stay put, Prof, because we have also a little souvenir for you as our gratitude to PICES and also to all researchers of marine societies. Thank you very much for coming to Indonesia. Thank you very much for coming to ITI. And we hope that you can come here again for other proposals. All right. Thank you, Prof. Mark. Okay. Now we are moving on to the next agenda, our pinnacle agenda for today. That is the signing ceremony for implementation agreement. So the first agreement is the implementation agreement between the North Pacific Marine Science Organizations and also Agricultural Industrial Technology Study Program, Institute of Technology Indonesia. The first signee representing the North Pacific Marine Science Organizations will be Professor Mark Wells, and to represent the PICES, and also representing Agricultural Industrial Technology Study Program is Insinyur Sinta Leonita as the head of Agricultural Industrial Technology. We are now preparing our documentation for implementation agreement. I invite Ibu Sinta and also Prof. Mark to have a signing ceremony. So this is our second signing ceremony for implementation agreement. After we have done with Sigitera poisoning joint research, we are continuing our joint research for creating Phytoplankton-Fishery observing program. Prof. Mark Wells will represent PICES as representing Prof. Makino. Okay. Yeah, just a little bit sign. Right, you may continue between Ibu Sinta and Prof. Mark. Perhaps we'll start together. You can sign together at the same time, and then moving on to exchange the document. And then, yes, you may exchange the document and then continue to sign again. Right. Thank you very much. Please erase the document, Prof. Mark and Bisinta, because we have to capture it. Yeah, hold on. Yes. Okay. Yep. Thank you, Ibu Sinta, for signing the implementation agreement. The next signing ceremony for implementation agreement is between PICES and also Chemical Engineering Study Program. I invite Dr. Insinyur Wahyudin to be here to also sign the documentations. This is our second signing for implementation agreement. Professor Dr. Insinyur Wahyudin is the head of Chemical Engineering Study Program. So beside between PICES and also Industrial Agricultural Technology, we also have the signing ceremony for Chemical Engineering Program, also PICES. You may together sign the documentation. All together, and next is you may exchange the document, and then again for the second time sign the document. Okay, after signing the document, please raise the document to capture the moment between PICES and also ITI and also BRIN. Ibu Dwita. Okay, I also invite our vice rectors, Ibu Dwita, Prof. Dwita, and also Pak Sidik to capture the moment to have a photo session together. Yep. Okay, please raise the document. Perhaps Ibu Sinta can also join with also the document. Thank you very much for all the parties to have a documentation signing ceremony. You may please have a seat. Thank you very much. Our next agenda is the ceremony for handing over the equipment, plantoscopes. We have the equipments that needs to be handed over between PICES and also ITI, Institute of Technology Indonesia. Before, handing over the plantoscope, we need to have another signing ceremony for it. Yeah, we need to have a signing, we need to have a document that needs to be signed between Prof. Mark, Pak Marzan, and also Pak Sasa. Yeah, it is very important for having this kind of document so that it will be officially handed over from PICES and also ITI and also BRIN. Pak Jaka. Pulpennya masih ada kah? Can we have pen? So these two plantoscope equipments as Prof. Mark already explained, this is a low-cost tools for recording and also assessing the microscopic images of phytoplankton communities, and PICES kindly grant these equipments to ITI to be used for the benefit to our campus and to Indonesia. Right. Yes, you may sign, Pak Marzan and Pak Sasa. Okay, you may exchange again and then sign it again. Yeah, in front of you, to all IT students, in front of you is the images of the plantoscopes. This is the plantoscopes that Prof. Mark already explained from his introductory speech. Okay. Yeah. Okay. Yes. Memberikan, ya, simbolik. So everyone, this is the plantoscope that Prof. Mark already explained in his introductory speech. Thank you very much to Prof. Mark, to PICES, for giving us this very useful equipment, tools for phytoplankton. You may have a seat again, Professor. Right. Now, ladies and gentlemen, students, and also distinguished guests, we are coming to the highlight of our agenda. But first of all, photo session. Okay. Before our continuing our agenda with the general lecture, I invite again for the photo sessions to all the guest lecturers, to BRIN, and to also head of study programs which are coming here, to our rectors, to our vice rectors, to have a photo sessions for a bit time. Yeah, it is very important to have a photo sessions, Prof and Bapak Ibu sekalian, because we need to have a documentation for every activity, national and international activity that we conduct in ITI. Yes, I invite also researchers from BRIN, head of study program, guest lecturers, guest researchers, PICES members. Ada lagi? Sudah, thank you very much for all the guest lecturers, the researchers, PICES members, leaders. Okay, thank you very much, Pak Sasa, for coming here in this occasion. Yeah. We will start our general lecture, everyone. This is the highlight of our occasion for today. Okay. Okay. Thank you very much for all the guest lecturers, to BRIN and also to leaders of ITI. We are coming to our highlight of our agenda, that is general lecture. There are 5 guest lecturers which are already here, all of them, who will give the lectures related to phytoplankton, related to their joint research. There will be Prof. Mark Wells, Professor Charles Rick, Dr. Shion Takemura, Dr. Naoki Tojo, and also Pak Arief Rachman. And this general lecture will be hosted by Professor Professor Dr. Suhendar Sasumar. Let me firstly give you a bit curriculum vitae information related to Prof. Suhendar. Perhaps all the students of Agro-Industrial Technology or TIP sudah mengenal Prof. Suhendar. But those who are not quite familiar with Prof. Suhendar, he is one of our lecturer and he is professor. Prof. Suhendar is a professor of Fisheries Resources Management and Coastal Oceanography in the Research Center for Environmental and Clean Technology from BRIN National Research and Innovation Agency. And also a lecturer of Agro-Industrial Technology, Institut of Teknologi Indonesia. He graduated from Doctor of Science or DSc from Department of Earth Science System of Technology, Interdisciplinary Graduate School of Engineering Sciences, Kyushu University, Japan in 2002. He also served as the Director of Center for Development, Education and Training of BPPT from 2014 to 2020, and also Indonesian National Group Leader for Physical Oceanography of Japan Society for the Promotion of Science, GSPS, Asian Core Program to establish research and education network on coastal marine science in Southeast Asia. Without further ado, please welcome everyone, Professor Dr. Suhendar I. Sasumar. Professor, the time is yours.
Okay, thank you, MC Garizi. Good afternoon, everybody. So we are happy that this session we will continue with the general lecture. So good afternoon, everybody. Thank you for your presence and welcome to join on the general lecture on the creating a phytoplankton-fishery upstream program for sustaining local community in Indonesian coastal water, which will start soon. So here already present is Professor Max for Maine University. Maybe he's maybe just introduce to all of you that Dr. Wes is a professor of oceanography in the School of Marine Science, University of Maine. He has published over 100 research articles, right? In peer review journal on topics ranging from marine chemistry, in phytoplankton zoology to algae and functional food. Yeah. He also known as his book in the factors leading in the harmful toxic algae blooms, and has organized international conference to consider how climate may after their pregnancy.
Di kampus nih.
Also known for his books on iron limitation of phytoplankton and carbon export, right, in oceanic waters, and how this limitation may change in the world. So I think it's time for us, if it is possible, it's 15 minutes, right? Yeah, so please.
Well, thank you very much. So this morning we talked a bit about planktoscope, and what I want to do now is just give a little bit more in-depth talk about what planktoscope is and how it works. But before, and you've seen the planktoscope, it looks very complicated, but it actually is very easy to use. Once it's set up, it's very easy to use. But first, you know, what we want to do is we want to think about the base of the food web. What do fisheries depend upon? They depend upon the plankton that produce the food, the phytoplankton. They're plant-like cells, single cells that occur in the water. This is, again, a global image of chlorophyll in the surface ocean. Chlorophyll is something that all phytoplankton have, just like the trees outside, makes them green. And satellites are able to detect that greenness based on the spectra of light coming back from the ocean surface. So one of the issues that we're concerned about is the amount of chlorophyll that's there. But the other thing that we're concerned about is, well, what is it that's making up that chlorophyll? So if we were to zoom in on any one of those green areas, you would find single cells that have a great diversity, a great variety of types of phytoplankton. These are all microscope images that show you a huge range. There's tens of thousands of species of phytoplankton that occur in the ocean. Not everywhere, but when you spread over the entire ocean. In any given water, you probably have at least hundreds, if not thousands, of species present. And they all are very specialized in what they do. They photosynthesize and create sugars and energy then that help feed the higher trophic levels. But they come in very different shapes. Okay? So while we're interested in the amount of chlorophyll there, and it's not just that the highest chlorophyll means high fish productivity. That's generally found, but even where you have low chlorophyll, you can still have large fisheries. Think of the tuna fisheries. The tuna fisheries are found in areas here that are blue, which means there's low chlorophyll. Okay? So it's not a clear one-to-one relationship, as we say, but you want to try and understand that base of the food web, those phytoplankton, if you want to try and understand your fisheries. The other aspect from that is to think about not only who is there, not only from the perspective of how does it support the fishery, but some of those species produce toxins to us. And we don't know why they produce those toxins. It doesn't seem to play a big role, as far as we can tell, in their ecology, but they produce organic compounds that end up being potential neurotoxins for us. And the problem becomes is when those neurotoxins make it into the food web. So what we're interested in doing then is quantifying not only the amount of chlorophyll, but who the phytoplankton are, and in particular, can we identify ones that can be problems to us? So that's where planktoscope comes in. So what is planktoscope? It's essentially a microscope. It takes images of plankton in a water sample. Now, this is the image here. Here it is here. I wasn't sure that I'd have this, so that's why it's there. It basically pulls water through. And if you think about a microscope and a microscope slide, you can put a drop of water on the microscope slide and you can look at the phytoplankton there. But what planktoscope does is it changes that water frequently and takes images frequently. And so it collects images of phytoplankton, and phytoplankton identification is based on largely their morphology, almost exclusively their morphology. In other words, what shape do they have? So planktoscope is a microscope that takes images of plankton in the water, and it can automatically count each type of phytoplankton. Once you train it, it has to be able to recognize what that image basically is by its shape, by image analysis. It's relatively inexpensive compared to many other instruments out there that can cost tens of thousands of dollars. Planktoscope will cost something on the order of $500 to $600, and you can make it yourself. The plans are there, okay? So what is it? How does it work? Essentially, it is a microscope. It has a, sorry, my thing, it keeps, there we go, okay. It has an image chamber here. It has, you put a source of water that goes in, it flows into the chamber, throws through the chamber and out into the waste. And as it does that, it's taking images through a lens with a camera, and that goes basically to a computer and a GPS locator, and you can, it wirelessly through Wi-Fi will, or cellular, will transmit those images to wherever it needs to go, okay? So the idea is all that you have to do is put a little bit of water in there, turn it on once you've tuned it and understand how it works, and it collects the data and sends it through the cell phone to people like Arief, okay, who right now can look at those images and he can recognize what they are. This part of the project that's coming up is to try and develop AI, artificial intelligence, machine learning, to identify what those species are. So it takes an image that has many phytoplankton in it. And so it will take the raw image here, takes the raw image. There's a bunch of, you can't see from the back, I'm sure, but there's a bunch of little phytoplankton there, and it basically cuts little squares around all of those little phytoplankton images, separates them, and then loads them into a program called Ecotaxa online. Ecotaxa is a platform that'll put images of things that you know you've identified into, and then you give it unknowns, and it looks for the same shape, and it'll identify it based on the library of pictures that you put in. And Arief is putting in those types of pictures now in order to train it for Indonesian waters. So these are an example of some of the images that can be collected, and Ecotaxa can look at each one of these and identify what they are. They're all the same species, all in different orientations and shapes, but the training library has been sufficient that it can identify what that species is automatically. Okay, so that's basically what planktoscope is. And the idea is that you can use this instrument then to get a sense of who is present in the water column. And when you're looking for relatively few species that may be a problem, you have to look at a lot of phytoplankton. And so that's what the power of this instrument is that rather than sitting down on a microscope, as Arief will more than be able to tell you, the hours it takes to look through a sample to identify everything, planktoscope can do in a matter of minutes. And so this will give a great power for understanding what the composition of the plankton are and be able to look for those particular problematic species. In our case, we're looking at it for other species that you may be particularly interested in. So I will end there, and there are resources that you can go to look at more on planktoscope. If you just look up planktoscope.org, you will see all sorts of images and possibilities. And we're hoping that in this presentation, we will stimulate you to think about the types of projects perhaps that as undergraduates, you might be able to embark upon, perhaps using an instrument like this. and I'll end it there.
Thank you for Professor Max. It's very interesting talk about talking with phytoplanktons and the device, how to identify planktons, right? Maybe the discussion later. So please keep everybody the question for the next discussion session. The next speaker is who is Dr. Sean Sang. It's okay. So we would like to introduce Dr. Sean Takemura. Please hold it. Dr. Sean Takemura is a senior scientist in the Socio-Ecological System Division Fisheries Stock Assessment Center, Fisheries Resources Institute in Japan, Fisheries Research and Education Agency. His fields and topic of research are coastal fisheries management, landscape ecology, and citizen science with emphasis on natural resources management. Within PICES, he is a member of Human Dimension Commission. He is involved in the PICES, MEV, VCI, Sigurretera, and Fish Phyto project to develop a continuity-based coastal monitoring system based applying with local fiber. So time for it. 50 minutes, yeah.
Thank you very much, Professor Sendar. First of all, I would like to thank Professor Sendar and ITI teams for providing this opportunity to introduce our research. Good morning, everyone. My name is Shion Takemura. I'm a researcher at the Japan Fisheries Research and Education Agency. My background is landscape ecology, so I'm ecologist. But now I'm really interested in ICT solution, so such as smartphone application. So today I'm talking about our smartphone application that have developed in PICES MAF project over 6 years. I would like to introduce background of this research. The marine environment has changed dramatically in recent years. So have you ever felt ocean change? No? So ocean color or ocean water temperature or yes? Yeah, so that is very important information. For this, I conduct workshop with local fishermen in Japan, and they said there are a lot of needs from small-scale fishers for a platform and or tools to report and share information of the ocean conditions. So change of the ocean. So heating seawater or akashio or etc. And not only ocean condition, and they want to share the reality with stakeholders, not only fishers. So government officer and local researcher. So a lot of stakeholders in order to adapt to ocean climate changes, because ocean is dramatically changes. But we face a lot of challenges for the adaptation to climate change in data limited small scale fisheries management. First one is to detect change in the ocean ecosystems. So we need to know the condition, but sometimes it is difficult to measure assessment. And second one is to share this information rapidly among stakeholders. So if get the data, but sometimes difficult to share. your with the stakeholders. And third one, to use it for the decision making on the adaptation measures. So we face these three challenges, but ICT tools such as smartphone, AI, and SNS tool are expected to be a breakthrough in solving these challenges. Yeah, I think ITI has a lot of solutions about smartphone and information technology, and it's a very powerful PC that is very helpful for the local community. So I'd like to introduce our smartphone application. It's called FishGIS. So this is target user is local fishers, but not only local fishers. Of course, government officer and students, university students, and professors. Everyone can use by free. So FishGIS is tool for reporting photo of ocean conditions. So this is a photo of fish and photo of water color. FishGIS can be installed from Apple Store and Google Play, so you can download. But if you use this application, you need registration procedures. So please let me know. So if you want to use this application. So I would like to explain three functions of the FishGIS application. First one is local fishers use a smartphone app to collect data. It's very easy. Just take a photo, group member. So let's introduce our example of fish photo collected by the FishGIS application. So already Professor Marzan already introduced this photo. So this is our research teams in Indonesia partners collect this photo. These photos tell us a lot of so many fish is sitting in the fish market. So barracuda and horse mackerel on bonito, tuna, snapper, sardine, groupers. So these photos help to understand fish diversity and important fishes for local community in Lombok. This is Lombok. And this photo can, so we can analyze this photo like this. So this is report images and identify fish species. This is very about 5 minutes per image, so very easy. And after doing procedures, we can measure total length from the image. Then finally, we can get distribution of the fish size. This information is very important because this information tells us a lot of small fish of children, small juvenile fish is there or not. So we can know a lot of fish in the Lombok water. Then also we can know each size distribution for each fish species. So FishGIS helps to collect basic information on fish stocks For example, yearly and seasonal change of composition of catch. Second example is the hydrocolor application. Actually, hydrocolor application is developed by the Marzan's colleagues. Yes. And hydrocolor employ a similar methodology as a precision radiometer and ocean color satellite to estimate 3 key water quality parameters: turbidity and suspended particle matter and chlorophyll concentrations. And this application is also very easy. Just take a 3 photo. Gray card, 18% photographers gray card, and the incoming sky radiation. Take a photo of sky, then light leaving the water surface. Take a water. So gray card and sky and water surface. Just this application estimate water quality parameters. So if you have interest in this application, so please details are shown in the this article. And this is one example. So Arief-san and the Indonesian team collect these data. Then so hydrocolor helps to understand the change in the marine environment in Gili Island. For example, so very blue, we can know so water color is different between bloom phase and others. So this is final my slide. So ICT tools are expected to be a breakthrough in solving challenges for adaptation to ocean climate change in data limited, especially small scale fisheries management. The FishGIS application is a tool for reporting images of ocean condition. So fish image helps to collect basic information about fish stocks, and water color images, hydrocolor, helps to understand of change in the marine environment. But a future challenge is not only collecting data, but also establishment of the mechanism for local stakeholders to actively participate in the data accumulation. So, would you like to join our research team? Already? Yes. Yes. So, this is, thank you very much.
Thank you very much, Xion-san. It's very interesting talking with like Marzan. So Marzan introduced the new advice from Tanso, right? And Xion-san introduced the also new device for monitoring water quality and fish, identifying fish to protect our to sustain our fisheries resources, maybe the next speaker is Dr. Naoki Tojo-san. Dr. Naoki is assistant professor in the Faculty of Fisheries Science in Hokkaido University of Japan. He has worked as an international corporate in a variety of projects such as ODA project with multiple international donors. Currently, he is working as the project manager in the Blue Bronte project in Mauritius with Mauritius International Fund. Also, he designed a lead training program including value chain development for sustainable use of fisheries resources by Japan International Cooperation Agency. He is investigating in methodologies in sustainable fisheries resources analysis in local scales, with standing in development science and conservation biology in aquatic system. This respect is a comprehensive socio-economic, especially with the concept of blue economy, right? Is in the part of in his research interest. He is one of the member of the scientific committee, PICES of North Pacific Marine Science Organization. Okay, thank you. So please, your time. Okay.
Hello, everyone. Assalamualaikum. I was in Morocco as an expert over there for the in the ODA project, and it was great time working with them. It was nice to see the Muslim culture and learning a lot. Maybe you can teach me a lot of things. You know, today since here you are studying in the ITI, right? So technology is something you are interested in. This is good. Of course, always technology has a contents, and today I'd like to introduce some theory, something you don't like in the lecture. Maybe you were sleeping, but you know, since you are in the ITI, at first I want to mention the three kind of specific techniques you might wanna learn. On the other, because it is easier for you to focus. On the other hand, you want to know that story, his approach behind, okay? So one you want to memo about is a Bayesian approach in analysis. Do you know Bayesian statistics? Maybe not, huh? Bayesian approach, okay? Then second one is a SPR model, okay? Spawning potential or spawning per recruit. This is a kind of reference point to manage or assess the fishery stock or population, okay, in a conservation. The third one is a participatory approach to collect the data and the information. Those three things, at least, please note and think about it for your new innovative idea for in the future for the fishermen and also the conservation, right? So the title of the presentation is a practical approaches for research and assessment in data poor or limited situation with research technician. Originally, I was more like a tech. Then I remember this fish, Euracon. This Euracon is also called candlefish because if you dry them and stick that kind of paper piece and put the fire, you can use like a candle because a lot of fat in it, right? Then this guy, this little one, come to the river, and they are living near, but they just go upstream and spawn. All right. So then there's a traditional fishing over there. I remember this site because it was very satellite place. Only commercial landing information is available for this fish assessment. That's why I'm very excited to see this paper 2 weeks ago. I have a memories with the Euracon and the Columbia River. I was working as a research tech, and then look at the Columbia River. This is river, okay? At that time I fixed one boat, research boat, and then my friend and I planned nicely and then drove that boat to carry out the limnological survey. Then we thought it's a river. So we didn't bring any radio, just a cell phone. What happened was, in the middle of the water, our boat stuck. And I tried to call, but I could not reach the shore. This was very satellite place. That's why I was very interested in that paper. Like, oh, how did they do that? A good assessment over there. Think about it. You need to collect the fish information, look at the microscopic things, and then count the age. Do the statistical analysis. No. Do you think you can collect the sufficient data and information in such a condition? No. Well, the Columbia River is one of the example of data poor situation in reality. no sufficient data and information amount or quality for the present analysis and assessment because of history of monitoring. There's no scientific monitoring only today or only last year or something. Then satellite location like Columbia River. Then no sufficient design for the present alternative of assessment. Like you might have heard about like ecosystem-based management or something very fancy things. Of course, it's a way to go. Of course. However, can we do that with based on the past design of the survey or monitoring? Nobody care about it originally. How we can do that, right? So in such a condition, more others, but in such a conditions, we can have data poor situation. So how to resolve the situation? Of course, I'm interested in how those Eurocon case was resolved, but think about it, the approach. That about the data quality, we can handle it. Why? Because we have a brain, right? Of course, there's something limit always. We need to understand the data, like how much we can tell from the data and so on, always. But the data quality part, somehow we can find a way, but think about the amount, how we can deal with, especially. So maybe 3 probable alternatives I can suggest for you. One is an application of a particular analysis, like some sort of way to analyze, then kind of methodology using a variety of data and information, Then second, you're going to apply somehow low cost and low efforts method to collect the data and the information. The third one is a flexibly apply available information as indices, some data can be indexed, okay, I don't, because of limited time, I'm gonna go very quickly, but the Eurocon case, then what the paper said was this is kind of report like a paper. They mentioned about their assessment methods. They used the knowledge of industry, So industry had a kind of history, time series of history. They have experiences, they have knowledge. Then in such a Eurocon land, maybe fisheries next year is declining and so on. They have information, like ecological knowledge, okay? So then they use that as an indicator or index, and then they set that on very simple management scheme, like 1, 2, 3, level 1, 2, 3, like a switch. So when they find, based on their experience, when they find such a situation of land or catch, they're gonna decrease the catch or increase the catch. They set a very clear standard, based on the knowledge with some supplemental survey of lava. Lava means a little fish, okay? So lava means what? This is like a recruitment, so-called. This is like how many fish can come back, potentially, right? So they integrated those little quick monitor, not quick, but those on-site monitoring, what they can do, and their knowledge to assess this Eurocon. Then some of you might think like not using knowledge maybe really sketchy or like something like can we trust that? Well, actually we do that often. Here I introduce the Bayesian approach. The detail, maybe you want to check out, you want to do some research about students especially. This is very important statistical things. But Bayesian approach is this way. Let me make it simple. All right, so if you go to the site, going to the fishing community, and they want to go for the site, but the fisherman said, no, don't go today. Why? You might ask, oh, because you see the cloud there. That cloud is a sign of rain. Don't go there. Do you trust them? Right. then you never do like a weather, like a special analysis, collecting those all time series of like a rain precipitation, comparing to the situation, like a, correlation. You don't do that, but you trust them and you do the survey. Do you think it's scientific? But scientific, isn't it? No, feels like no, but scientific you are doing because they trust. What is the border of that? Bayesian approach is similar to that. Basically, based on the probability of prior information, one of that parameter related information, you're gonna take it and then use as a reference and then predict the predict the precisely with that condition, what's gonna happen? Try to narrow down your answer or decision. Okay. So some people might discuss this Bayesian approach as like a little subjective or something. But the story behind is that exactly that. You never do that weather forecasting study or something, right? For that choosing over the survey day. It's exactly same things. This is a Bayesian approach. I don't go for so much story about it because it's gonna be so detailed. I can talk like a whole day. I love it. I don't talk about it, but think about it. But the fisheries assessment, by the way, basically have like 6 steps. This is based on the punt and hillbone, but especially step 2, determining relative probability. This one, how you gonna determine this like a relative probability or reference point here? The Bayesian approach will be applied. This way, we can narrow down. We don't have to do the wasting. We don't have to waste our efforts. We can be efficient to design our survey or research, right? So Bayesian approach is one of the methods to applying this particular analysis to be efficient with a data limited situation. Okay. Here still like a Bayesian, it is not easy to calculate without data and information, but possible to find with the helps. So we're gonna get the help from the prior information. If we use the Bayesian theory, we can write like that: posterior information or posterior distribution of the information or data is based on the prior information as a reference and marginal. By chance something happened, and then with likelihood. Maybe some of you heard about likelihood function and likelihood likelihood methods, right? Basically, you can apply the likelihood methods here, plug it in. Then you can calculate, you can try to find a costless, effortless, and something number, or even like a prediction based on the Bayesian theory. Okay?
Sudah itu dan di-share. Saya dapat dari
Right, little bit change topic, but it is the analysis component. So to assess or to analyze the fishes for the fisherman or country, whatever the purpose is, we really need the age information. Then this is from Japan. This is also from Japan. The Japanese fish or temperate fish, they have like these rings of the ear, in that otoliths, this is the bone in the ear, and also the scale. You can find how you can find a change because of their life history change. Year by year, there's a season in Japan. Their food, the availability of food condition for the growth is different. So you can find this record upon those things, How about Indonesia? What do you think? Do we have seasons? Yes, but do you have a clear season for the fishes? Yeah, sometimes like yeah, two. Yeah, that's right. But into the tropical fishes, maybe it's not always true, right? It's always they have food, they are happy. Hey, you know, like Nemo is doing well, you know. Nemo is always happy, right? Always happy. I love Indonesia, you know, that way. But we cannot find that sometimes annually or annual rings. So to do the assessment based on the age or something, Indonesia or other country in the tropical conditions often has a difficulty, data and information limited situation. All right. So there's a good study using like a daily links, counting tediously the daily links because there's a rhythm of day, right? But imagine how much it is tedious, how long time, what equipment is necessary, you know, not always practical, right? So there is a so-called the size-based LV standard SPR model. So what is it is basically using a fish ranks, which Shion-san talked about with our project. Maybe some of you wondered why we collect the size of fishes, right? Yeah, it is true. One, like a very simple, the size is declined, and maybe it's a sign. Of course, that component is extremely important, especially for the locals. But for the assessment, not only that, size can tell you that, you know, the age. Even you don't know the exact age, let's assume you collect all fish and then, you know, classify them based on the size. Maybe you can separate them out. Small ones, big ones, maybe some overlap. Those things may be telling you that the age, right? Then here is a von Butterfly, von Butterfly, the curve, like there's a standard age, and this is standard size. So if you align this distribution and then find the statistical clusters, you know, then you can align them along the then you can find this equation. You know, see, this is a medium size, little bit large size, small size. You have the frequency distribution here. You can find another frequency distribution here. You can separate them out statistically, right? Then you can find the best fit model, right? If so, if we can do that, tada, we can get the parameter out of it. Based on this growth equation, you can find a very important parameter, including like a SPR spawning potential or spawner per recruit. You know how much how much you can have a spawning potential, you know, out of that, you know, the fish, you know, you can calculate, you can back calculate what, you know, what you can estimate out of that this, you know, model. That's why it is very important to collect the size, especially here. We need your help, and you need to join to contribute, work together. Okay. All right. Then just a reference. Generally, reference point is a SPR. If we calculate that the SPR is more than 20%, it is increasing stock in the future. This is a 20%, it is maintained. Less than 20% declining. You can use it, you know, for that reference based on that the references. And then, you know, good news for you, it's free. Yeah, you can find the internet, but this is what I learned. Unfortunately, I don't find the time. I can show you later if you want. But you can. This is R free software, right? Some of you knows this is a statistical package. Also in the internet, you can freely access and you can calculate too. But based on the size, you can get the parameter. Just this moment, even now, I cannot open because of time, but you know, you can obtain the reference points as a parameters based on the collected size information with the best fit, von Barton-Fee growth equation. Okay. That's why my student is working in Mauritius. They are working with fishermen and then just put the fish like that, like a Shion-san, Mark-san show you. Take a photo from a certain angle, you know, and then you can imagine it is easy to measure the size. And you can get the histogram, and you can get the best fit curve. But okay, naturally moving into the data collection. So just now we saw the fisherman join. Can they trust them as a data collector? My answer is yes. Why? Because data collection, the quality of data is a matter of what? Not a matter of people. It's a matter of training. Don't you think? It's not a matter of from where, what they are working for. You know, how much they can be serious is matter. You know? So here is the so-called citizen science example in a conservation Christmas bird count. Since Christmas in 1919, you know, so they are collecting the information by the bird count. Like, oh, this bird we found, this bird we found, collecting all over the US and Canada, everywhere. And then even you can find a scientific paper based on that. You know, matter is not the people. Matter is a training and a skill and technology from your innovation. So in our project in the past, fishermen joined the data sampling and collection. And then even they try to improve themselves based on what they got. So then they even get a report and so on. Very quickly, advantage of this participatory approach, for example, fishermen. Advantage is potentially low cost. You're gonna buy the lunch, you're gonna have a consensus. Of course, you need to build the trust. And then potentially small efforts for the sampling. You don't have to go to the site if you train them right. This advantage is not always controllable. We cannot force them to go everywhere there. They have their, you know, they need to eat, right? So maybe the effort, sampling effort is limited spatially, right? Especially ecological data. But then from a perspective of development, maybe only the advantage I can find. What it is information will be interactively shared with everyone. Some fishermen might say to you once you enter the agency, you know, agency never report to us. Agency folks might say, well, how can we express what we found to them? You know, always there is a trouble. But automatically, by having them as a member of the data collection, they will understand at least what is going on, and they can communicate to you. It is a big advantage in a developmental perspective. So, of course, precondition is sincerity. This is my Thailand friend. He is tall like this, like near 2 meters, but always sitting down, try to talk to them, you know, one by one. And the 109 fishermen, who never joined to the cooperative, came to the workshop, you know. You need to develop the teamwork with them. And then proper facilitation and sufficient information sharing is necessary. Fisherman has high potential, so I really recommend to communicate to them. This is also Indonesian project. I'm gonna just a little shorten the explanation, but based on the game experiment, they are better to cooperate each other and they share the sustain the resources. This is a game experiment with the Hokkaido University student. Compete which one is better to sustain the resources without consultation. Fisherman won. Okay. So this is a case study in the Mauritius. They join and studying how to measure the size with a fish picture. And they are trained and they are practicing. Not only just practicing, we also did the activity like reporting and cooking with them. They wanted to have a Japanese food. So we made a sushi together, and then see so not only data collection, involvement is very important, and it can help you even to develop your technology. This is a case study from Sri Lanka based on the value chain model. We needed to collect the household information and then find the topic, find the problem of that household. What we did is what we did was a workshop, and then they themselves pointed up those points, and also themselves organized the information of the how much cost, minimum, maximum, and general, and the frequency distribution can be developed from there, and we can use it for the Bayesian approach. Why? We have distribution prior. Why don't we use that to interpret other things? Right? So see, this is an example from socioeconomic even. You have a potential young man, so you need to communicate to them and involve them. Then you're gonna be involved to find something new. And then don't forget, not only just collecting the data with the tools, but also different way of thinking to improve the analysis methodology. Thank you very much.
Thank you, Tojo-san. It's very interesting how to solve the reset with the full data. Because of time is up. Maybe the next speaker is Arief, right? Maybe before Charlie. So Arief will deliver about research results of the hub and Seguatera in Lombok. Maybe we can introduce Arief is Arief Rahman is Arief Rahman M.Bio. is a junior scientist, peneliti muda katanya ya. Peneliti specialization in the studies of the marine phytoplankton with main research interest on the relation between phytoplankton, zooplankton, and physical chemical factors of tropical marine ecosystem. He also known of his research on the ecological dynamics, ecological dynamics of harmful harmful algal bloom species of Indonesian and inactive members of international harmful algae blooms research groups in the SPS and IUCS. In research, yes, he also works to find a method to automation the cell counting and identification process using artificial intelligence and machine learning. He's the current leader of marine microbes of plankton research group in the research center of oceanography. This is a problem. Okay, so so please.
Okay, thank you very much. Sorry for a little bit of technical difficulties. So today I'm going to talk about the harmful algal blooms, and part of our studies of Ciguatera Indonesia in Lombok. So this is a little bit more technical than the other presentation. So I hope you can continue and try to understand what I'm going to present. So earlier this morning, Marzan has already informed us about the harmful algal blooms. So in general, the harmful algal blooms is the rapid uncontrolled growth of the microalgae, small phytoplankton, that could cause many damage to the aquatic ecosystem. That is why it becomes known as one of the 10 plagues of the sea by the Duarte et al. In 2014. And the occurrence of the harmful algal blooms, this is the example of a case in Padang in Bungus Bay in 2019. The waters become very green. It caused the ocean discoloration. After the ocean discoloration, it follows by the fish kill, the mass fish mortality. A lot of fish died in a matter of days in this particular area. And also it can cause toxin contamination. That's why part of our studies is looking at the ciguatoxin. Mark already explained about the CFP and the toxin itself in the presentation this morning. And of course, when it happens, it also disrupts the balance of the ecosystem. And because of this fish mass mortality and the toxin that they can produce, it poses a danger to the health of the human. And of course, if it happens, it will damage the economy of the coastal communities that are depend on the sea when their harmful algal blooms occur. So a little bit about the ciguatera fish poisoning, just a reminder. So it's a poisoning disease caused by the ciguatoxin that are produced mainly by this particular species, the Gambia discus toxicus. But in the recent years, we have found more evidence of other species that might produce similar toxin or might be associated with the case of CFP or fish mass mortality during the blooms of Gambia discus. The other genus that we are targeting is the Culia, Osteropsis, Porocentrum, and the other one that I did not show here is the Ampidinium. Like Mark already explained this morning, it's very difficult to actually know the symptom of CFP because some of the symptoms are very similar with the seafood poisoning. But sometimes we can look at some specific symptoms, like if you have reversal hot and cold sensation, like hot become cold, cold become hot, there might be a symptom that you might have something other than the normal food poisoning, especially combined if your muscles or your joints are starting to pain and you feel tingling and numbness. That's the sign that you have not an ordinary seafood poisoning. It might be something else. So this is all the data that we have for the benthic dinoflagellates. That's all. And the only person in Indonesia, among more than 250 million people, there's only one expert of the benthic dinoflagellate, which is Ibu Riani Widiarti from University of Indonesia. So we don't have that many data. So like Tojo already said, we are in the data poor situation on the benthic dinoflagellate and the CFP. And we don't have official records or maybe any records of the CFP in Indonesia, but we have studies that are conducted in several areas in Indonesia, including in Gili Matra, where we are working. So our research basically looking at the potential threat of the hubs and the CFP in the Marine Tourism Park of Gili Matra. This is the part of the Ciguatera Indonesia project that was run from 2022 to 2020 countries, including because we have many Indonesia Ciguatera or a CFP problem from many different scientific perspective. So we have more elaborate, more full pictures of the Ciguatera, and because we don't have many data on CFP, so we have to gather as much data as we can, and that was what we did in this project. So this part of the studies, we aim to identify the potentially harmful species. We also would like to look at the anthropogenic pressures and the potential economic loss that could be caused if the hubs or CFP happens in Gilimatra. And also important thing is to disseminate information that increase the local awareness of the potential dangers of harms on CFP in the local communities. So this is our study area, the Gilimatra Marine Tourism Park atau Taman Wisata Perairan TWP. Gilimatra consists of 3 islands, Gili Trawangan, Meno, and Air. This is a very important conservation and tourism area. It protects about 2,000 hectares of waters around this island and home to many different important coastal communities. And this island and the ecosystem are very ecologically vital to some protected and charismatic species, like I have shown in the slides here. For example, sea turtle. I personally feel and meet with the sea turtle when we do the sampling in Gilimatra. So it's very, very beautiful area. So for the sampling sites, we have 16 permanent sites that we collected the data for 5 different seasons for the water column. Similarly, we also get benthic dinoflagellate samples and data sets from 6 permanent sites that we also collected for 5 different times across 4 seasons in Indonesia. So this is just to show what we did. We collect the plankton samples, we measure the water column parameters, and we collect the benthic dinoflagellate from natural substrates like coral, macroalgae, seagrass, and also use the artificial substrate. And we also try to implement new technology to capture the ciguatoxin directly from the water column. And we also conduct the socioeconomic sampling. And also we collect some fish tissues from the local markets and the local fishermen. This is just part of the data. We have a lot more data than this. But so far, from just one island, we have identified over 200 species of phytoplankton, in which 17 of them are potentially harmful species. But we similarly using the estimation technique like Tojo-san has already explained, to estimate how many species that actually there from our samples. So from our calculation, we still missing about 40 species from our current efforts. So this is the microscopy image of the 17 potentially harmful species in Gilimatra. For example, important one is the Trichodesmium because they blooms in the several seasons in our studies. But the other ones are potentially toxin producers, like Pseudonychia could cause amnesic shellfish poisoning. The Satonella is known for fish killer. It become a big problem in Japan. And Carania, similarly, can cause neurotic shellfish poisoning. Similarly, it also I heard a lot problem with Carania in Japan as well. Xenophysis that are associated with the Proracentrum. Whenever the Proracentrum is in high density, they always occur in high density as well. So this is how seasonal variation in Gilimatra, for example, I used the Gilimeno, are different from season to season or from our sampling site. The most interesting one is that we have a very high and dramatic increase in the cell density during the wet season. This trend was also reflected in the data set of hydrocolor that we collected. And also, Sion-san already explained. I will also show that the hydrocolor also able to identify what type of species, or when we compare the data, it matches. And then season to season, they are different, except when there is a blooms or the domination of the cyanobacteria in dry season and transitional season 2, the species composition pretty much are the same at that time. So this is how the species composition and domination between group change between season to seasons. And there is a blooms of cyanobacteria or domination of one species. This is the Trichodesmium erythraeum, which blooms during August and October. This also reflected in the hydrocolor dataset. If you remember Sion-san graph, there's 2 different sets of data that are very high in here and very high in here. It reflects different groups of profile and different type of pigments. it could be captured by the hydrocolor. This is something that we are trying to look deeper and to see if we can actually use that to model if we found this signal of color very high in the hydrocolor, what species they're actually blooming. This is something that very interesting. The other things that we also use this complex statistical model, but actually all of you might have seen something like this, but this is from the RDA analysis. We wanted to look at how each genus are correlated or related or regulated by different sets of parameters. For example, the Trichodesmium, they are more abundant in the waters with the higher salinity and the higher nitrate concentration, while the commonly dominant Chaetoceras, the diatoms, they are more abundant in warm, turbid water and rich in phosphate. And some of the example of the potentially harmful genus also have different sets of the parameters that affect their density in the water. Now, for benthic dinoflagellates, this is also interesting because the same blooms is also occur with the train of the benthic dinoflagellate is the same with the phytoplankton. We also see a dramatic increase in the total number of cell density during the wet season in December. But the trend in different type of substrates, the artificial coral rubble, macroalgae, and seagrass are quite different. The one that are very similar is macroalgae, but different trend we found in seagrass. So there might be something that are affecting this very opposite trend in our data set, but we haven't been able to found the cause of this type of trend. So from this data also, we saw that Procentrum is the most dominant or most abundant benthic dinoflagellate in our group. They're potentially toxic gambia discus. We found them finally, but the density was very, very low. It's in the same data set, same level as the Ostreopsis, so it's very hard to see in this particular graph. Now, for the substrate preferences, we wanted to look at if there are some species or some genus prefer some type of substrate. And we did found that Procentrum, the most abundant one, they tend to be abundant or they choose the living substrate like macroalgae and seagrass as their living substrate. But the other genus like Ostreopsis and Coolea, they like non-living or dead December, affect the population or cell density of different type of genus of benthic dinoflagellate. For example, the Procentrum, they are abundant at Gilead, which has a higher temperature, warmer water, higher pH, and then the water's more turbid. While the Ostreopsis, they are more abundant in other islands in Gili-Meno, which has higher salinity and clearer water. The other things that we have done is to look at the existence of the ciguatoxin itself. We used the M.Si and we collected, in total, we collected 31 fish samples from different sampling expedition. So far, we did not found the indication of any ciguatoxin in the fish tissue from the fish that we collected from the local market and local fishermen. So, but the problem is mouse bioassay is not very sensitive. It depends on the ability of the mice that we use for the test, the mouse that we use to test, to show any sign of sickness. Because we don't see that sign of sickness, there is still a possibility that the concentration of ciguatoxin might be there, but it's still below the concentration that are required for the mice to get sick and show some symptoms. So we need a more detailed chemical-based analysis such as ELISA. And in some part of our studies, we use special tools called the S.Hut. It's a filter that can capture the ciguatoxin directly from the water column. But the problem is the filter needs to be analyzed in a very specific laboratory and in France. So for now, we haven't been able to analyze the S.Hut filter, so we don't know if we actually has the ciguatoxin concentration in the water column. This is another important part of how our tools that have been talked through this morning combine to become a mitigation plan or to become a line of what to do when the harmful algal blooms or when you see something strange in the water. Fish are behaving strangely, they like a drunk fish, or they suddenly jump out of water, a lot of them jumping out of waters, and maybe some fish started to die. We can take a look at this, included the reporting section for the red tides or the harmful algal blooms. Some experts or some locals can also help with collecting samples. The easiest one, when you have bloom, you just cook with this glass or with this your water bottle, and there will be there a lot of them. And then some of the local experts can also look at the species composition. We are planning to use this as one of the tools, planktoscope. And we can also use the foldscope as a very cheap way of looking at the cells on the field. And then they can help inform the data, or they can collaborate with other scientists, academics, to try to look at what species is there, what we have to do, how we're going to disseminate this to the people, etc. And the local people could also help report the findings to the local government. And in this current age of viral sensation, you can upload your findings in the social media to get, in the hope it become a viral post, so you have more awareness from a lot of people. Because right now we see that if it's not viral, it's not known, and government will not going to do anything about that. So as hard as this as a truth, viral sensation become very important in the reporting of the problems in our countries. So other than that, the most important thing is this one: do not and never consume any shellfish or dead fish that was collected or catch from the impacted area, because we never know what causing the fish to die. If it's just oxygen depletion, I don't know, it might be safe, I'm not sure, and I did not recommend to eat any of them. But if the dead fish are died because of the toxin, if you catch it, you eat it, you become sick, that's a big problem. Okay. So this is what we have done in past, and we are still, and we have a community preparedness, and one of the dissemination tools, as we give posters to several communities in Lampung, Ambon, and also Lombok in a long time ago. So just a brief conclusion. In general, we found some species that are problematic from our studies, but so far the only one that are most abundant is the Trichodesmium erythraeum, which is also known to blooms in several areas like Jakarta Bay and Pari Island. And for the benthic dinoflagellate, especially the toxic M.Bio.Sc, we found them, but the cell density is still very low. So at this time, or at least in our studies, we see that it has only a small risk to cause CFP. And because we did not detect ciguatoxin in our analysis for now we can say that for now, at least from our studies, the fish that we collected from Lombok are free from the CFP. But you have to remember that if the coral reef and environmental degradation or deterioration continues, it will provide a more suitable condition for especially the benthic toxic species to blooms, because many of the species like M.Bio.Sc, they're able to tolerate and even grow better if the water quality are very low. I think that's all for my presentation. I have to thank all of the people that has been supporting our research on the field, on the institution, because without them, we cannot do any of our works. I think that's all from me. Thank you very much.
Thank you, Pak Arief. It's very interesting. There is a lot of research results from the CFP, Gotera. And please keep the question for the discussion session. So the next, maybe the last speaker is Professor Charles Lake from the University of Toronto, Canada. So before that, we would like to introduce Professor Charles Lake. Dr. Charles is received his PhD. His PhD in oceanography from the University of British Columbia at Canada. He has been an academic for 40 years, primarily as the Endowed Ivy Chair for the Ecosystem Health in the Scottish School of Medicine and Dentistry at Western University of Canada. Presently, he is the inaugural professor and director of the Institute for Health and Wellbeing at the University of Toronto at Institut, then direct research which blends planetary health, public health, and community wellness. And then his work in marine ecosystem has allowed to embrace the socio-economic of health and citizen science. Along with colleagues, they have friend community members of the centers. And the next is creating a world engaged in reaching sustainable development of goal 14, life in science. So it's time yours.
Okay, hi folks, how are you? I don't believe you. As a director of an institute on health and wellness, you are in trouble because you've been sitting there for almost 3 hours. Okay, so I'm going to give you a 3-step program to revigorate your feelings. So first step, would you please stand up? Okay, step 2, I know you can do this, okay? I want you to reach high, both hands, and twist. Come on, baby, let's do this. No, twist your bodies, not your hands. Okay. All right. Now, wait a minute. Who said you put your arms down? Hey, up. Okay. With your hands up, I want you to high five 4 people around you. Okay, now you can give a little twist and go back to your seat. Now, you know, it kind of seems silly, but those are really ways of which we try to get the blood to move through our bodies. You know, I could then suggest that you could punch the person. That would invigorate them, but the high fives matter. The twists matter, and standing up really matters. Okay, so I have the privilege of having the last faculty lecture here. Okay, and I'm going to remind you that there's a purpose for everything you have heard this morning. All your good scientists have told you their specialty, and each one of them recognizes that there are data which indicates that the world is good, and there is data that indicates the world of fisheries is bad. Okay, so they're not just collecting data, they're collecting information to make a decision. So how do you know? You say 5? What's the population of Indonesia? Now, I've been traveling a lot. I am in Indonesia, right? Yeah, okay. How many people are in your country? Would you say 270? 270 million individuals. Do you have enough fish to feed 270 million people? You think so? How do you know? That's going to be the question. Here's how you think you know. When you go to a restaurant or when you are serving dinner at home and fish is there, then you assume that there's enough fish for the other 270 million Indonesians as well, right? That's what you're thinking. And if you have fish day after day after day, or a couple times a week, then you say, well, the fisheries must be good. So why are we worried about this? Well, we're worried about it because the rest of the world and many of the scientists associated with fisheries science don't agree with you. They think you are living by drawing fish from the future. And my job is to have you think about the future and whether you can have what we call sustainable fisheries. I worry that you have a sustainable public health. Okay. Now, why are we worried about fisheries? Because fish gives us protein. They're a staple of our cultural experience. There's a variety of different fatty acids that it provides to keep you healthy. So I'm going to talk about public health and social aspects. The social aspects just mean the population or the community. And it's the last point here. So if you want a little tagline, this is the tagline for the day. We've seen a lot of data. We want to know, are we going to arrive at the proper destination? In other words, are we going to be able to understand what all the data means when we piece it together? That's the most important thing, because I know not all of you will become oceanographers. Okay, I'm pretty sure about that. All right, but you can be advocates for understanding that the quality of the ocean waters, which is what everybody's talking about here, matter with whether you have fish on your plate and whether it's good fish, whether it's contaminated fish, and whether your health would be good, not just for you, but for the next generation. So here's what the world thinks. Okay, it's a little hard to explain, but some people that are a lot smarter than I have gathered all the information of the coastal waters around the world, and they've asked the questions, are there lots of fish, and are the numbers of fisheries going up, or the number of fish in those areas going down? And how fast are they declining, or how fast are they growing? They've chosen 5 areas in this world that they view as ecological hotspots. This is not the hotspot that you want to be involved in. These are the ones that have the 2 problems. The number of fish are declining, and they're declining at excessive rates compared to the rest of the world. These are the 2 scores here. One is whether things are declining or not. The pictures didn't show up very well, but it really doesn't matter. Indonesia's up here. The stocks are declining remarkably. And the rate of which it's declining in Indonesia is higher than most other places in the world. Now, that doesn't sound very positive, does it? Projects like this one help you gather data to manage your own projects. Manage your own environment. Manage your own fisheries if possible. So they're not snapshots in time. They're opportunities for you to look forward to the future. Now, if you look at the quote up here, it says, these maps depict changes in global cumulative human impacts on the ocean. So these are how humans are having an effect. But what we're really going to be talking about today is a second one, and on changes in the ocean sustainability and food safety. What's sustainability? Now, this is where you stood up, you sat down, you slapped each other around a little bit. you get to tell me what is sustainability when it comes to fish? What is sustainability when it comes to chickens? What is sustainability when it comes to your life? I thought. I can tell you right now, you will both be right and wrong because there's no good definition of sustainability. So just give me your thought about sustainability. Now, I've taught for 40 years. I can wait you out. Or I can do the next worst thing, walk down there and make you talk into the microphone. Somebody say something or I'm coming. All right, I already got the guy picked out. Hi, what's your name? Are you from here?
My name is Andrian. Okay.
Are you an Indonesian?
Yes, I am from Indonesia.
And what's sustainability?
The continuity about the process, the continuity from the beginning until the last, maybe.
Okay, can you improve his numbers? His definition? Tell me your name first.
I don't understand. I not understand.
I'll go to the next group here. Hello, ladies. Who wants to tell me about sustainability? Come on, show this guy up. Okay, you didn't hear them because they're shy. But they said sustainability is the ability of a resource to replace itself relative to the needs that you're demanding from it. In other words, will that fisheries, the number of fish and the quality of fish, still be there after you've removed fish to maintain your environment? Isn't that what you said? Yeah, see, they're shy, but they got the answer pretty good. So the picture up here is simply this. Sustainability is actually bigger than this. Sustainability, now you speak. What's going on? I go over here with a microphone and nobody says anything. Then I go over here, now you speak. All right. Sustainability is a bigger problem than this. Sustainability is your relationship with the ocean, whether it is water quality, whether it is fisheries, whether it is aesthetics. The Japanese have lent us this idea of seito umi, which is a relationship one has with the marine environment. A sustainable environment is one where, yes, that environment will maintain itself and be happy or replenishing, even though we're asking a lot from it. And with 270 million people, you're asking a lot from the coastal waters, even if you don't see it every day. Okay, I'm going to get to the punchline here. If you're trying to assess in a project, I want you to get a mental picture of what the project looks like and how everything that these individuals talked about today fit in. So it's just called the 3E model: the environment, exposure, and the effects. The environment is what they've talked about today. What do you measure in the environment that will tell you something about how many fish are there and the quality of the fish? They could be things like ocean warming, nutrients in the water, benthic substrate, whether it's corals or whatever, and water quality and how much light is there. All of those will affect either the safety of the fish or the number of fish or the type of fish. Sometimes they will increase it, sometimes they will decrease it. How much is in this box here tells you something about the effects, and here's where the social aspect is. Do you have food that's not contaminated? Do you have enough fisheries to keep the jobs available and the economy going? Do you have enough on your plate to get enough nutrients every day? And do you have this complexity to keep your community or your family together? Because this is a big deal. Many fishing areas, they don't have enough economics, and their generation, their children must leave the area to go into like the big cities. This is not part of what we are measuring specifically in this project, but this is why we are doing it. We want to understand aspects on the left-hand side that will keep you having a sustainable relationship with marine waters. And here's how they fit in, just to give you an idea. Things that they talked about today, things like, hydrocolor, planktoscope, fish GIS, they're all measuring aspects of water quality. And from there, you have some differences in how many types of fish there are, how many phytoplankton, that's food for the fish, etc., nutrients, and whether ocean warming is having an effect. You throw all of those ideas together and you get a prediction of what will be happening on the effects here. So the problem with this project, not the problem with the project, but the way it's been presented is that we're offering an idea that you collect all this information together, you put all the data together, and then you do what you just did. You stand up, you wiggle your butt, and you give high fives saying, I've done a good job. But you haven't. Because all you have now is a bunch of stored data. And we need scientists, we need technically advanced mathematical individuals, or just curious souls to be able to take that information and run it backwards to tell us what future generations will look like. Will there be fish? Will the quality of the fish be there? Will the diversity of the fish be there? So this project, and most of the projects that we do with PICES, relate to the fact that we need individuals. We're going to create a new generation of scientists and promote the progress of science and advance the health, prosperity, and welfare of communities or nations. Very noble, but you have to complete the cycle, not just collect data. Okay, so that's it. Thank you very much.
Thank you very much, Professor Charlie. We still have 30 minutes, maybe discuss. So please, if there is somebody who wants to ask to Professor Max, to Dr. Sion Takemura, Dr. Tojo, Professor Charlie, and Pak Arief. Ya. Nanti mungkin nggak tahu nih ada di from the WhatsApp there is something. Ayo mahasiswa dapat reward kata Pak Syahril. Tanya. Ada. Sebutkan nama dari fakultas mana dan ditujukan ke siapa. Ya. Silakan. Pakai bahasa Inggris ya.
Okay. Good afternoon, everybody. Allow me please to introduce myself to you all. My name is Andrian Rustandi. I'm from Mechanical Engineering, and I am now 6th grade. Okay, I want to ask about the phytoplankton. We know the explosion of the population of the increasing the phytoplankton, which is graded by increasing level of phosphate and nitrate in water, which result of cause in rapid algae growth and a rapid decreasing in oxygen on a local scale. Maybe manufacture from the highest from the phosphate and nitrate, and down and now how to deal with or follow up the incident with the photoscope or fish geese application to make this incident to be clear. Maybe just this for me.
Okay, thank you. Yeah, maybe I just good question. Maybe everybody can ask them. Maybe the first two, Marzan. You.
So the comment and the question is, how would you use the planktoscope in those situations? Yes. Okay, so if you're looking at a major event, so Arief talked about some of these major blooms. So you could use the planktoscope to get an idea about the numbers of the plankton that are occurring in that water when you see the color, when you see the problem. So you know what the threshold is. It's probably easier when you have really strong color just to use a regular microscope, because normally when you have really strong color in the water, like that green color, it's usually only one species that dominates. So you could look very quickly and determine which of those species is that's controlling that. We call it a phytoplankton bloom. Okay, the planktoscope is probably more useful before it gets to that stage. So we sort of think about a musical production where you have many different actors, but you don't know who's going to sing the loudest, but you want to know who all the actors are. That's what the planktoscope may help you with. But when somebody is singing really loud, you can use a regular microscope to figure out who that is. Does that make sense? Yeah? Does that answer your question?
Maybe there are many methods to analyze. I have to use the fishbone analyze to find out the problem, Mister. And then so manufacture and I find out the root cause or the problem. They are for healthy and safety, and the others in this in my place in Jakarta, there is Seribu Island. There is the name Phytoplankton is Coscinodiscus SPP. Yep. There is not a danger phytoplankton, but there is so much big population. There is a big contribution for the produce the oxygen, but because the highest population is need more oxygen, and because of that, the more of fish are dead. Maybe just
Right.
from me.
Yeah, so what you're describing is a problem that is not just in Jakarta Bay, but in many parts of the world, in nearshore areas. It's the problem is that if you think about photosynthesis means you take CO2 and water in the presence of light, and you make organic matter and oxygen, right? Okay, so when plants photosynthesize, they make sugars, okay, fixed carbon we call it. When we eat that, we respire that material, that organic matter. And it's just basically that same equation of photosynthesis, CO2 plus water gives you organic matter and oxygen. It just runs in the opposite direction. So you take the organic matter and oxygen and you produce CO2 and water. So where the problem is when you get to this we call them hypoxic events, is you have a big mass of phytoplankton in the surface waters. They produce a lot of oxygen. There's no problem with oxygen there. But when the nutrients run out, the phytoplankton die. And when they die, the phytoplankton, when they're alive and they're reproducing, they have buoyancy, okay? So they kind of float. They stay up near the surface. But when they die, they lose that buoyancy and they sink down into the water below the photic zone. They sink down into water which is colder. The deeper water is colder. That water doesn't mix with the surface water because of the temperature difference. And so you have the organic matter and oxygen being produced at the surface, but they sink and then respired by bacteria in the deep, and they use up the oxygen in the deep waters. And that's why the fish die, because of hypoxia. Now that type of bloom is a harmful algal bloom, but it doesn't mean that there's a toxin produced necessarily. Most of the times there isn't a toxin produced. Most of the time it's just high biomass at the surface. So Cosca nidiscus could be the organism that happens to bloom. But it's not Cosca nidiscus as a species that causes the fish to die. It could have been Cattosaurus. It could have been any other type of phytoplankton that blooms in the surface. And when they sink, they die. There is an organism that's very recognizable called Noctiluca that blooms in the surface. Okay, it's a dinoflagellate, something totally different group of phytoplankton than Cosca nidiscus. They don't produce toxins, but because they're high biomass and they sink and die, they use up the oxygen in the deep waters. So when we're talking about, say, planktoscope, for that type of event, planktoscope doesn't really help us that much, because you can look through take a little bit, put it under a regular microscope, you can figure out who is the dominant phytoplankton, because normally when you have a bloom, it's usually one or maybe two species that are the most abundant, and you can easily see who they are under just one slide, okay? Planktoscope is more useful when you're looking at times well before the bloom to figure out who is there. Does that make sense? That's a very good question.
Thank you for my question. Is there anybody who want to add? Yeah.
Okay, let me introduce myself. My name is Muhammad Adam Rafli, or you can call me Adam. I'm from the Agro-Industrial Technology Department. I want to ask a question. What are the parameters that you use to indicate the success for this program specifically, the Phytoplankton-Fishery Observing Program for Sustaining Local Communities? What are the parameters that will indicate the success, and how long do you think that this program will succeed in Indonesia? Thank you.
Okay.
That's a very good question. And that's one of the first questions that funding agencies ask us when we write a proposal. How are you going to measure success? So in this case, success is not as much a direct output, but it's an indication that the observing system is working. In other words, that we see data coming in. It's not, success isn't that, oh, we found, say, Ciguatera fish poisoning. That's not what or that we didn't find it. That's not the measures that we're looking for. What we're looking for is a indication that the community, the local government, the people there are being involved in producing or collecting the data that can help indicate how their environment, what state their environment is in. So that really is the only measure of success. Now, as far as where we hope to go, this initial project or initial focus in Lombok is really for us to try and figure out, are we doing things right? Are we putting the right effort in the right places in order to get the data coming in? How do we tune? Who do we talk to? How do we involve community members? How do we involve university students, university professors? What's the best way to get that we call synergy going? Once that's kind of figured out, which we hope is going to happen within this project, then we'll begin looking at other locations in Indonesia to try and take that design and apply it there. And ultimately, what the goal is that what we transfer here in the way of tools and understanding and the use of data will become self-sustaining, okay? So Charlie talked about sustainable fisheries. What we're hoping for at the end of this project and what we would measure as success is a sustainable application of these types of ideas to get the data you need to understand the state of your fisheries, to understand the state of your seafood safety. Does that answer your question? Good. You need to go and work for the government funding agencies. Other questions? Oh.
I have one more question. From the lecture, there is a species of toxic phytoplankton, right? Is there any specific place in the Indonesian waters where that type of plankton is very abundant, or is it in every waters, or is there any specific place? Thank you.
I'm going to turn it to the local expert here.
Okay.
Okay, thank you very much. A very good question. So we found many at this time. We found 17 species combined with the some benthic dinoflagellates. If you remember the map of the benthic dinoflagellate I show in the early in my slides, that's where the other that species was have studied or recorded in our data. For others potentially harmful species that we found, there are many actually. In general, they will always exist in all types of coastal and oceanic ecosystem. The key is the density. The density usually are very low, except for the cetoceras. They are very abundant. They are common in Jakarta Bay. In many highly eutrophic waters, you can find a lot of cetoceras, and it has caused some problems. Fish mass mortality in Jakarta Bay several times was caused by cetoceras. Not only because of the oxygen depletion that's already explained by Mark, because the cetoceras can block the gills of the fish. They can kill the fish by physically blocking the gills, the cetoceras. The other types that are blooming here in Gilimata, the Trichodesmium, has reported bloom several times in Jakarta Bay and Pari Island. And some other species that we found was has not been a problem in Indonesia, because actually, if you wanted to know more, we can discuss, because we categorize some species that has been recorded blooms and species that has potential bloom, means they bloom in other countries but not in our countries. And if you remember in my first slide that I said the blooms in Padang, in the green blooms, it was caused by Noctiluca, also already explained by Mark. So in Indonesia, we have couples of blooms happen every year. I did not show in my slides because it's gonna take, I don't know, this should not be a 15 minutes presentation. It should be 2 hours lectures instead to explain all of them, because there's so many data, there's so many instances that we have recorded and we have studied about the blooms, including if you look at the internet, you search for paralytic shellfish poisoning case in Cirebon in 2016 to 2018. There are more than 100 people was affected by paralytic shellfish poisoning. 2 people died at the time. So that was also some of the problems, the real problem of poisoning that happened in Indonesia. So we did not want CFP to happen because it complicates a lot of things. So to answer your question, yes, some of the species are also recorded blooms in Indonesia and causing problems, but not all of them. Thank you.
One more. Yeah. One more 5 minutes. Right? Yes, one. So ladies.
Hello everyone, my name is Amanda Putri Safitri from Chemical Engineering. How can we control the phytoplankton? How make the toxicity to make a develop for fish quality in Indonesian Ocean, and what the fish biomass we can create from the fish who have the toxicity. Thank you.
Okay, if I understand your question, it is what the last part was, what proportion of the fish would have the toxin? Is that what you mean? Yes. Okay. So right now, based on the data that we have, which is not enough, it appears that there are very few fish that have high enough toxin levels that it becomes a problem. It's likely that most of the fish have some toxin levels, but they're so low that it doesn't affect us. In other countries, in many cases, in other tropical countries, it used to be that there was very little toxin in the fish. So if we think of the Caribbean islands, they did not used to have much ciguatera fish poisoning. They used to be okay to eat the fish, but now they tend to have much higher levels of ciguatera fish poisoning because the toxin levels in the fish have gone up. And what they have shown is that the relationship is because human development has led to more nutrients going into the coastal waters. And the more nutrients have led to an increase in benthic dinoflagellates in general, and also an increase then in the benthic dinoflagellates that are producing the toxin. And so that with time, that toxin has been accumulating through the food web, and now they're at levels where a lot of the fish have significant amounts of ciguatoxin in them. So right now it looks like in Indonesia there's not much, but that's why we think it's so important to try and get this type of observing system in, so that if you start to see increases in the abundance of these problematic benthic dinoflagellates, then maybe you can stop that by maybe stopping nutrient input or somehow improving the environment to make sure those populations don't get high enough that it gets through the food web. Does that answer your question? But you had a first part of the question, which I forgot what it was.
Well, should we control the growth of phytoplankton that's make toxicity?
Yeah. Should we control it? We would love to be able to control it, but we have no idea how. What is called, what you're talking about, they're starting to turn to in North America is mitigation. In other words, figuring out how can we slow the growth of toxic phytoplankton. They have mitigation they've used in Korea and also in China for quite a while, where they see a bloom, they have a different species of phytoplankton, doesn't matter which one. They have a different species of phytoplankton that kills bivalves. And they grow bivalves. It's a big industry. And what they do is they spread clay, getting more of the regular phytoplankton, and everything's okay. But if you're talking about a reef environment, you can't kill all the phytoplankton. You'll kill the reef. So controlling the abundance of these individual species, we can't do that yet. At some point in the future, maybe we will be able to, but we're talking when you're as old as I am. Okay. Good questions.
Okay, thank you, Professor Max. I think because of the time, it's I'm up. So before closing is the lecture session. Huh? Oh, there is a gift for the for the for the student. Okay, please come. Maybe Pak Rector mungkin ingat sih siapa Mas? Oh, ya. Tadi siapa yang datang? Ya? Please come to. Ya. So maybe there is a gift for a student. Okay, thank you everybody. Maybe before closing of this season, we would like to slightly resume what the result, the result of the lecture of the from pipe expert of oceanography from PICES and also Indonesian maybe So here is I already prepared the resume something there. Okay. Maybe the first resume we would like to read that marine ecosystem driven by the production of plankton like a single cell organism known as a phytoplankton. Their production can be roughly estimated by measuring chlorophyll concentration. Not all phytoplankton are beneficial to the marine system. Several species produce potent neurotoxin, which when and bioconcentrated in food waste can disrupt marine ecosystem and pose a threat of human health. For this reason, it is necessary to look for technology to determine its existence by using advanced science and technology as per fishery state, namely the plankton scope. Namely a tool that is cheap and efficient and capable or quick recording microscopic images of phytoplankton community. When combined with the machine learning method, the presence of problematic phytoplankton species can be quickly assessed. And the second, that is the technology for monitoring environmental condition of water and fishery resources by using advanced technology of artificial intelligence, ICT, and smartphone, such as the hydrocolor and PICES technology has developed globally and benefits our life because of its practically and speed in obtaining data and information about environmental condition in waters and fishery resources. And the third is the program creating a fishery phytoplankton observation program to sustain local communities in Indonesian water is a multidisciplinary collaborative research program that culminated in an important aspect of the PICES mandate, creating a new generation of scientists by promoting scientific progress, advanced property and well-being of the community of nation through guidance and mentoring from PICES and other funders. PICES apply fisheries expertise and harmful algae bloom to improve the public health by improving water quality or adaptation to thinking about public health or public economic health. And the fourth, in the reality of fisheries on ecosystem, it is difficult to find sufficient quality and amount of data and information for the research and assessment required for sustainable management action. It is also a fact that a large number of local people live livelihood are often highly dependent on available specialist resources and ecosystem with uncertainty. For that, we have a discussed approach that can be put to practice in data poor and limited situation for sustainable action, especially with fishing communities, in order to examine the quality of data and level of resolution of data and information. The approaches and their combination were carried out for research and assessment in data shortage or limited situation. First is applying a particular analytical methodology using a variety of data and information. The second is applying low cost and low effort methods to collect data and information. And the third is flexibility, apply the probability information as an index for conducting research and assessment in data for limited situation. It is advisable to use a combination of both with local people involved in the data collection process and understanding officers and ecosystem. And the last resume is that CFP or ciguatera fish poisoning is one of the problems caused by the occurrence by toxic benthic hazards algae bloom, which are triggered by damage to coastal ecosystems such as seagrass bed and coral reefs. Cases of CFP have not been reported domestically. Species of toxic benthic dinopelagata have been reported and studies in several areas in Indonesia, including in Gili Mata and Lombok. To that, and identification of potentially dangerous species has been carried out, estimating their potential damage to ecosystem and local communities, and disseminating information about the potential hazard of HEB and CAP to local communities, and raising awareness from research. From research, such 70 species of potential harmful phytoplankton have been found on Gili Mata. The result also show that the seasonal change really affects in the community structure of the phytoplankton. Similarly, the population dynamic of the target benthic dinopelagata also show the significant seasonal differences. No ciguatoxin was detected in the red bioassay of coral reef fish collected from Gili Mata and not Lombok, indicating no risk of CEP in Lombok so far. However, strictly models show that increased stability, nutrient concentration, and disruption of ecosystem can trigger the rapid growth of HEB species, which are usually well adapted to low water quality. This further demonstrates the importance of proper management of key coastal ecosystem, particularly seagrass beds and coral reefs, to maintain their health and reduce the likelihood of HEB and CEP appearing among Gili Mata. That is the summary of general lecture. I think, thank you very much. So thank you very much for everybody who involved in this lecture. So the time is yours.
Thank you, Prof. Iskandar. Please have applause again for Prof. Iskandar and all the guest lecturers that coming today that have been explained all the very knowledgeable explanation related to the marine societies. Thank you very much to Prof. Iskandar and all the guest lecturers again. Ladies and gentlemen, students of IT, we are coming closer to our end of agenda. But before that, let us have a closing remarks from our Vice Rector.
Recording stopped.
Please welcome Ibu Profesor Dr. Dwita Swastianti to have a closing remark.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and greetings to all of us. As a Vice Chancellor of Academic Research and Student Affairs of Institut Teknologi Indonesia, thank the honorary, especially for Professor Mark Wells, Dr. Sion Takamura from Japan, from PICES, and Mark Wells from PICES too. Dr. Naoki Tojo from PICES, Hokkaido University, Japan. Professor Charles Strick
from PICES, University of Toronto, Canada. Mr. Arief Rachman from BRIN. Thanks for sharing knowledge and technology through general lecture title Creating Phytoplankton-Fishery Observing Program for Sustaining Local Communities in Indonesian Coastal Waters. It is very interesting lecture. Thank you. And BRIN, we will make maximum use of this equipment, especially for the agriculture, industry technology, and chemical engineering study program. Our appreciation is also given to Professor Iskandar as a moderator for general lecture activities today, as well as an idea initiator for holding this general lecture. We also thanks to the attendees of the general lecture activities participants. We hope that the knowledge and technology presented today will be useful for all of us. We hope that the result of this collaboration will benefit to all of us and contribute to develop science and technology globally, international world, including in Indonesia. Thus, we convey our closing remarks by saying Alhamdulillah. We officially close this general lecture event accompanied by congratulations and thanks to the PICES delegation, BRIN, and audience for continuing other activities. Thank you, and see you on other occasion. Thank you.
Thank you, Ibu Prof. Bita, for your closing remarks. Ladies and gentlemen, before really ending our agenda for today, we would like to have the last photo session.